Here's question number 42. So it states that e to the power of x minus 12 times e to the power of negative x minus 1 is equal to 0. And so we want to solve this. Now, if you want, you can again try this problem on your own here. You want to think of this problem in a different manner. It's quite challenging here, especially if you do not know the first step. So the first step here is obviously to understand that this is negative x, right? If you have a negative exponent, this obviously means that e to the power of negative x is equal to 1 divided by e to the power of x, right? You have a negative power while you do the reciprocal to the positive power. But here that concept will not really help us, right? But what will help us is to understand that if you have the same bases and you're multiplying exponents, and you can add their exponents, right? So if you have e to the power of 3 times e to the power of 2, the fact that these have the same bases over here, you can add the exponents, so this becomes e to the power of 5, right? You can add those exponents because they have the same bases. So that's just the exponential law here, the exponential rule that we talk about. So if we want to get rid of this, right, the best idea would be to multiply this by e to the power of x, right? Because if you multiply e to the power of x by e to the power of negative x, well, they have the same bases. You can add the exponents. Adding the exponents, you get e to the power of 0. Well, that's just 1. And so that will get rid of this complicated e to the power of negative x. So let's multiply both sides by e to the power of x. Right? So obviously here it won't matter. This one will still remain 0 because anything you multiply by 0 will still give you 0. And then you have this. So e to the power of x times e to the power of x will give you e to the power of 2x. Then you want to solve this part over here. So e to the power of negative x and then e to the power of x, right? As I said, you're adding the exponents. Well, that's just e to the power of 0, right, which is 1. So here we have minus 12, and then you have minus e to the power of x is equal to 0. Clearly, we have a quadratic function here, right? Because if you say let z is equal to e to the power of x, you see that here we have z squared minus z minus 12 is equal to 0, right? And if you solve this, this becomes z minus 4 times z plus 3 is equal to 0, right? And obviously we know that z here is e to the power of x, so we can say that e to the power of x minus 4 times e to the power of x plus 3 is equal to 0, right? And so we can solve this further, and we see that e to the power of x is equal to 4, and e to the power of x is equal to negative 3. So we have these two equations over here. Again, we can put this in the form of logarithmic form here. So we can say that log base e of 4 is equal to x. Log base e of negative 3 is equal to x. We have these two problems here that we want to solve. And log base e of 4 is really just ln of 4. Log base e of negative 3 is ln of negative 3. Now, if you want to evaluate ln of negative 3, there is no solution. And that makes sense, right? There won't be any solution if you were to evaluate ln of negative 3. And again, the reason is, is it ever possible for you to say that e to the power of x is equal to negative 3? Well, no matter what exponent you have, e to any power, or really for any exponent or any base, when you have that exponential function, you will never get a negative value, right? E to the power of negative 1000 may bring you really close, really small. The value will be really small and will just become closer and closer to 0, but it will never be negative. Therefore, it should make sense to you that ln of negative 3 has no solution, because e to the power of x giving you negative 3 is not possible, right? And then ln of 4 does have a value. Ln of 4 is equal to x here, right? Ln of 4 is equal to x. So if you evaluate this in your calculator, you should see that ln of 4 is equal to 1.386. So for this problem here, question number 42, we see that x is equal to 1.386 rounded to 3 decimal places. So thanks for watching.